Hello everyone. In this video, we will learn why it is important to use GeoServer and what GeoServer is. A typical mapping application gives you the tools, maps, and demographic data you need to analyze and understand how geography affects you and your business. Modern-day computing systems, with ever-increasing computer power and storage capabilities, have extended the use of mapping applications manifold. When it comes to the deployment of mapping applications, we usually have two broad options. Desktop GIS. This allows you to manipulate your map and save all the manipulations locally in the desktop. It gives you the possibility to keep your data private. Examples include ArcMap, QGIS, etc. The second option is to use GIS servers. While desktop applications might be suitable for small-time works, we need to understand that real-world GIS applications require huge resources. They need to deal with hundreds of data formats, multiple rendering technologies, and serve different mapping requirements while serving multiple teams simultaneously. This is not possible through standalone desktop GIS applications. This need is served by GIS servers or map servers. In its most basic form, Map Server is an application that sits inactive on your web server. It gets active when a request is sent to Map Server. According to the request, it processes the mapping information stored in its associated databases and serves the mapping image to the client using one of the standard web services protocols like WMS, WFS, tiles, etc. On the input side, it is closely coupled with the data servers and stores, which store the basic mapping data sourced from various data sources. They may be online data sources or offline as well. And also, they may be vector sources as well as rasters. WMS or Web Map Service, WFS or Web Feature Service, and WCS or Web Coverage Services are the web service standards from the Open Geospatial Consortium. These allow web clients to query and receive geographic information in the form of image, vector, or coverage data. WMS is probably the best known of these three standards due to its widespread use by map servers to deliver map images. On the output side, the rendered mapping output can be in any form as per the requirement. It can be in a PDF form, an SWF video file, an SVG image file, an HTML page, or simply a combination of an image and a web page. At the core of a GIS application, there is an operating system driving the hardware, which in most cases is Linux. The basic data is stored in general-purpose databases like MySQL, PostgreSQL, etc. A layer of spatial database software like MySQL Spatial and PostGIS extend the capabilities of spatial information processing these databases, and the combination becomes a spatial database. On top of it lie the desktop applications like GRASS, QGIS, etc. And at the same time, there are applications like Map Server, GeoServer, Map Blender, OpenLayers, etc., which extend the mapping capabilities over the web. Now, let us look at some of the basic features of a typical mapping server. A typical mapping server supports displaying and querying of hundreds of raster, vector, and database formats. It has the ability to run on various operating systems like Windows, Linux, Mac OS X, etc. It supports popular scripting languages and development environments like PHP, Python, Perl, Ruby, Java, .NET, etc. It ensures on-the-fly projections of maps in different projection systems. It ensures high-quality rendering of maps in various formats as per the user requirements. The output is usually fully customizable. With the help of the internet, clients can access the geospatial information of the web regardless of the fact that the server and the client might be far from each other. Map Server introduces distinct advantages over traditional desktop GIS, including: unlike desktop GIS, which is limited to a certain number of GIS professionals, map servers can be used by everyone in an organization as well as the public at large. This broad audience has diverse demands. Applications such as mapping street road, locating places to tag personal photos, tracing friends, and displaying Wi-Fi hotspots are a few examples. Most of the map server clients are web browsers like Internet Explorer, Google Chrome, Mozilla Firefox, Apple Safari, etc. because these web browsers are compatible with HTML and JavaScript standards. Map servers that relies on HTML clients will typically support different operating systems such as Microsoft Windows, Linux, and Apple Mac OS. The geographic data and maps can be presented to the world through map servers. Anybody located anywhere in the world can access the geographic information from their computers, desktops, or mobile devices. In general, the traditional desktop supporting GIS application software is used by only one user at a time, while a map server can be used by dozens or hundreds of users simultaneously. Thus, map servers provide much higher performance and scalability than a single desktop GIS. The vast majority of content on the internet is free of charge to end users, and this also applies in map servers. Generally, users do not need to buy software or pay to use map server services. Organizations that need to provide GIS services to individual users can also minimize their costs through map servers. Instead of buying and setting up desktop GIS for every user, an organization can set up just one map server, and this single system can be shared by many users, from home, at work, or in the field. Desktop GIS is intended for professional users with months of training and experience in GIS. Map Server is intended for a broad audience, including public users who may know nothing about GIS. For desktop GIS to be updated to a new version, the update needs to be installed on every computer. However, for Map Server, one update works for all the clients. Let us now try to understand what actually GeoServer is. GeoServer is an open source server written in Java that allows users to share, process, and edit geospatial data. GeoServer conforms to the Web Feature Service or WFS standard and Web Coverage Service or WCS standard, which permits the sharing and editing of the data that is used to generate maps. It also uses the Web Map Tile Service standard to split your published maps into tiles for easy use by web mapping and mobile applications. GeoServer is a modular application with the additional functionality added via extensions. Now, let us look at the user interface of GeoServer. I have installed GeoServer on my local machine, so I can access GeoServer on localhost. The interface of GeoServer is extremely user-friendly. The left side menu gives all the relevant links to access different sections of the application. Now let us look at layers. The term layer refers to a raster or vector dataset that represents a collection of geographic features. Vector layers are analogous to feature types and raster layers are analogous to coverages. Here are the different example layers which get installed automatically when you install GeoServer. Now let's go to Layer Preview. This is the Layer Preview section, wherein the different layers can be visually seen or downloaded in different formats. GeoServer supports a huge variety of formats to serve every individual need. The commonly used formats are given here in hyperlinks, whereas the other formats can be accessed through the drop-down menu. This is an example where I have rendered the data of the US states in the Open Layers format. This window also contains the layers uploaded by the user. This is a layer about the roads in Columbia State, which I downloaded from OpenStreetMap dataset and have uploaded on GeoServer. Now let's move on to workspaces. A workspace is a container which organizes other items. In GeoServer, a workspace is often used to group similar layers together. Now let's learn about stores. A store connects to a data source that contains raster or vector data. A data source can be a file or a group of files, a table in a database, a single raster file, or a dictionary. For example, a vector product format library. The store construct allows connection parameters to be defined once rather than for each dataset in a source. Now let's learn about styles. Styles are used to control the appearance of geospatial data. Styles for GeoServer are written in a number of formats like SLD, CSS, etc. Clicking on a style opens the style page, wherein you can see the code of the style. As you can see, styles are encoded in XML format, which is easy to understand and edit. After editing, you need to publish a style and map it with the layers you want that to be associated with. From here, you can also see the various attributes for a layer. That were the basics of GeoServer and MapServer. Thank you for watching.